Okay, yes. So thank you for those of you who made it. I guess most people already went home at the end of today. So today I'm going to talk about testing GraphQL and how you can do that in a way that you're testing all the functions of your GraphQL server or maybe your client. So today won't be about explaining what GraphQL is or how you can use it. It will mostly be about testing. So also if you are in that experience with testing, you can figure it out during the slides. So a lot of people actually don't test their code. So especially big companies are doing this. They've got all these load balancers. They got like 1,000 servers, or maybe they're working serverless. They usually don't really test their code because as soon as something breaks, they will see it in the metrics and users won't do it. But if you've got smaller applications, or maybe you want to have an idea about your code stability, then testing is a good idea. So when testing in production, always make sure that you have load balancers, or if not, just implement testing. So a little bit about myself. So my name is Roy. I mostly work on open source projects for the City of Amsterdam, where we're building sort of a data hub for all the open data that we have in the city, and we open source it using Python APIs, also a little bit of GraphQL, and mostly React on the front end. I also teach GraphQL at the React GraphQL Academy, and I work with other companies as an advisor. So why write tests? So there are a lot of reasons to actually write tests. Some are like big reasons, some are smaller reasons. So I highlighted some of the reasons that I use myself when I try to get people to testing. So one of these is check if code behaves as expected. So you're writing a function, you want to know if that function actually works the way you expect it, or if maybe an entire code block works as expected. So that's for me the main reason to actually test my code. See if it works as I expected, and in the end, it will save you a lot of trouble. And those trouble you will get saved when you're testing for errors and edge cases. So usually you make exceptions in your code, and there are stuff in there that only you know or only your team knows about. So if you have to hand over this project, then it's really hard to actually see why these exceptions are there. And if you put testing in place for these exceptions, it's really easy to understand them and why they're there. And there are probably a lot of more reasons on a high over level that are important when applying testing. But for me, these are like the high over stuff I use when talking to product managers that actually have to pay for all the time that goes into testing. So a bit more practical reasons is it makes refactoring easier. Because a lot of time when you do refactoring, you're changing a lot of your code, and then in the end, maybe your functionality is broken, or maybe you've broken some of the functionality that you didn't know was there. So if there was a test case for your edge cases, then you probably would have found it. But otherwise, it makes refactoring easier, because if you assume this simple function, so you're actually taking the average of two variables, and you're dividing them by 2 to find out the value. So in your test case, you're just checking if the average of 2 and 2 is 1, sorry. No, 2. Jeez, it's the end of the day. So if you would refactor this function, and instead of dividing him, you would do it times 0.5, it would have the same result. And so your test won't break, so you can refactor all this code, and this is just a simple function. Suppose it was a really big function, and the output should be the same. If you would have testing in place, you can still see if your code works as expected. And this is just for like a simple pure function. If you've got bigger functions or more complicated edge cases, and you don't have any testing in there, you probably will break functionality without even knowing it. So another thing is improving your code quality. So as you saw before, like just an easy test, it already improves your code quality because you can refactor without breaking stuff. And also, a lot of time you're debugging things because you don't know where things went wrong. And something I experienced when testing a lot, like difficult, complex code that's complexly written, is really hard to test because tests are meant to be simple and easy, and your functions actually should be as well. So it's better to break up functions in smaller functions. In my opinion, it improves the code quality, and it also makes testing easier and debugging. So that's why testing is also important. And the last one is something I really like when I start on new projects. So every time you start a new project, you need to get familiar with the code base. And if there isn't any documentation, or the documentation is outdated, then it can be really hard to get familiar with that code base. So if you have a lot of testing in place, and you've written things down like this, then it becomes way easier because you can immediately see all the hidden features in the code. So actually you can use the test cases and all the test scenarios as documentation for your code. So you get an in-depth knowledge about what it should be doing. And especially if you apply stuff like test-driven development, then you probably have set up all your user stories like this, and user stories should be test scenarios, and then it becomes way easier to actually get familiar with new code bases. So if you want to apply these things to GraphQL, basically it's all like high over, you can apply all these patterns to GraphQL. But let's first look at what we can actually test for a GraphQL server or client. So we can test schemas, right? So if you use schemas and your schemas have certain types, and these are things that should be really easy to test. Or queries, will they have the exact same outcome as you would expect it? These are all things you can test by testing the schemas. And you can do the same thing for resolvers. So resolvers are actually the things that are getting the data for you. You probably want to test those because you want to know if either your database connection is set up straight there, or maybe some logic you apply there is working as expected. And probably you can also test more things on server side, because we've got schemas, we've got resolvers, we also got the actual server that is running. And something that you could do with some packages is actually load testing on a GraphQL server, which is quite interesting. Something we will look at the very end if we still have some time. So you would actually want to test the server as well. So not only the schemas and resolvers, but also how your server behaves, and even how it behaves if you put a lot of queries, if you send a lot of queries to them. Because maybe your queries are too complex, maybe your setup with the database is too complex. You want to know that, the same as you test SQL queries in other types of servers. Or you can also test it client side. And that's something we will see later on with the demo as well. And there are multiple ways to actually test it. So as you can see, you can do static type checking. So I would really prefer to use some sort of language that has static type checking. So either it's with TypeScript or JavaScript with some extensions, or maybe you're working with more functional languages. If you got static types in there, then the amount of errors between your actually schemas and your resolvers and how they will actually be outputted will be way smaller, because you're already checking the types multiple times, not only in your schemas, but also throughout your resolvers. So that's something that's really useful. And unit tests. So also we have a lot of unit tests in place, so you can unit test maybe your schemas, your resolvers can have unit tests. And integration tests, so you want to know how your resolvers and schemas work together, or maybe how your resolvers work together with your database. That's stuff you would test in integration tests. And we might also have end-to-end tests, so maybe you want to test the entire life cycle, so from your schemas to your resolvers to your queries, and actually how it would end up in your client. So end-to-end tests will mostly be applied on the client side, and then we can later on make it a version between mocking stuff and actually testing against your live or your test databases. So there are multiple strategies you can apply when testing code. So a pattern that used to be really popular was this one, so like the testing pyramid. You would have unit tests at the bottom, then you have integration tests in the middle, and you probably have end-to-end tests on top. And the reason behind this was because unit tests are relatively easy to make. They cost you less effort because they're really testing small units of code. They can run quite fast. Integration tests are a bit slower because you're already testing multiple layers of code. Maybe you're testing the integration with schemas and resolvers, or maybe resolvers with a database. So this slows it a bit up. And end-to-end tests are especially slow, because they involve like multiple products maybe. So maybe they involve your client, they involve your server, they involve your database. So throughout your entire code stack, it will involve basically everything. So that's why they run really slow, and usually they're harder to make. So this is a pattern that used to be really popular. If you ask a lot of product managers, it's more like this, because they don't really care about unit tests. They only want to see the actual outcome of your test. So they want to see, maybe with something like Cypress, how actually users are going through your code. Is your login flow still working? Can people still pay? So a lot of product managers actually prefer this one, because it's really visible for them what's actually happening. While as a developer, you want to see if your code is working, and then probably it becomes easier to debug things of functionality later on. So another pattern that's become really popular is the trophy one. That's right here. So what you would have here at the bottom, you would have static type checking. So that's actually where you would start. So by using something like TypeScript or maybe a functional programming language, then you would have static type checking. So that's the first portion. And then you would have some unit tests, because if you apply static type checking, it's less common to have a lot of unit tests, because you're already testing a lot of things that you would test in unit tests. So will my string be a string? That stuff you already have covered when you're checking your types. And then in the middle you would have integration tests, because they are a lot more interesting, because they actually involve multiple products in your life cycle. So that's why they are interesting. And then at the top you would have end-to-end tests. So you can see the division between integration test, unit test, static type mapping. They're all like less obvious. So this is a pattern I prefer actually. So first let's start at how we can actually test the schemas. So for this, on the left, you can see basic implementation of something, some part of my schema that I constructed. So this is a type for product. As you can see, it's called type product. It's got two fields, so you've got a title and a price. And to test this, you can look on the right side. So actually what we're doing there, we're importing the types, and we're actually really easy going to check if your type is your type as you expect it to be. So this test isn't that, you don't really get a lot of wins by this test, but it's good for your test coverage, although test coverage doesn't really say anything. But if you got more complex types, maybe you got variants or fragments in there, then it becomes more interesting to test stuff like this. So schema testing can actually be quite easy. So if you got more or bigger schemas, or maybe you've got remote schema stitching in place, you would have different types of tests. So a lot of packages you can use for this. So Apello got packages for this. And something I really like is Easy GraphQL. So you could install it from npm and you can run it on every JavaScript implementation of GraphQL. And stuff you can do with there is mocking. So you can actually mock results of queries and test against them, or you can actually test assertions right away. So here's like a basic implementation of how to actually get your schema. So with this lines of code, you can actually import your schema, maybe from a local directory, maybe from an external directory, to actually have your schemas in there so you can mock against them. And then a mock would look like this. So you've got your query on the right side, you implement some variables, and you mock it later on. So first is the query we want to test. So we want to get our product, and we've got one variable, which is the product ID, and we want to return some fields and also some subfields. And then you can define, you actually want to mock errors as well. So maybe you want to handle how your GraphQL queries will handle errors, or maybe how your server will handle it. You would do it like this. You would just define you want to mock errors as well, so you can test your error messages. And in the end, you can make assertions against these mocks. So basically, you're just mocking it, you're getting the result, and then it will be a JSON object, and you can actually see if the JSON object is as expected. So as you can see on the right side, we've got reviews, and apparently reviews is supposed to be an array. So everywhere in your code, you're going to assume reviews is an array. So you want to test those things in your assertions. So that's how you can basically implement schema testing as well. And something else you can do with Easy GraphQL Tester is making assertions directly. So you can actually test if queries or mutations will succeed. So that's done like this. So on the right side, again, you can see the same query as we just saw. And instead of mocking them, we're going to directly use the test assertion to see whether or not it's valid. So you can send in product IDs, you can do the same for mutations. And in here, it saves you a lot of code, but you got less knowledge about what actually will be the result of this. So it really depends on how you want to do this. Do you want to have basic testing for your schemas? You can do it like this. It's really easy. It's like making snapshots. You're done really quick. If you want to have more knowledge about what actually is returned by your queries, you would mock them and just see the results from there. So that's something you can find on the website from Easy GraphQL as well. There's a really nice demo that links to Sandbox, Code Sandbox, and in there you can find all those mocking and assertion things as well. And they go really far. They've got queries with variants. So it's really interesting if you're working with bigger schemas to actually test them with Easy GraphQL Tester. So resolvers, that's another thing we can test. So as we saw before, we can test schemas, we can test resolvers, and we can test more things server-side, right? So we can look at resolvers now. And something that's really important to know is resolvers are pure functions. If somewhere in your code base you have side effects written in your resolvers, you should get them out, because resolvers should be pure functions. That's how they actually were meant to. So with that in mind, you can figure out how easy it will be to test them. So suppose pure functions are like a black box, right? You put something in, and based on that output, something will come out. And you will know every time I put in a certain thing, like maybe every time I put in maybe some beer and friends, you can expect the same outcome, unless there are side effects. So maybe there's a pregnant girlfriend from some of your friends that is getting into problems, then you would have side effects. But assuming you don't have any side effects, you probably would have a good time when you put these things in there. So that's why resolvers should be pure functions. And if you want to test them and they have side effects, it gets really hard, because you need to define all those side effects. You need to define them as edge cases. How are you going to handle them? So that's why you really should try and make them pure functions. And if they are, This should be really easy to test, right? Because you will know every time I put something in this shape, something in that shape will come out. If I put something in with these fields, like that field will come out. It's something you should really have in your resolvers, because your resolvers are where you actually collect the information for your schemas. So if there are side effects in there, then it becomes really hard to test them later on when you actually test your queries. So in practice, if you want to test resolvers, that's something you can do with packages as well, but you don't really need packages, as they are just JavaScript functions or maybe Python or whatever language you've written your GraphQL server in. So assume this resolver. So it's really a simple resolver. It's taking an object, which is probably like the parent object for product. It has some context, so maybe it will get something out of the database there. And it also takes arguments. So leave everything beside. You will always know if you put an object in with like a review object in there, then it will return something based on that review object. And if there aren't any side effects, you can probably really easy test if you put something in that exact same output as you expected will come out. So you would test it something like this. So you would just import your resolver. You will set maybe an object that you want to have as input, and then you can just see if it still is the same result as you expected. So if you keep these as pure functions, it's really easy to test them. And also, maybe if you do some alterations to your reviews object, then still those alterations should be testable. So maybe it should be strange if you maybe change like field types or something else. And if you do, then it should be described somewhere, so you can actually test it. And so for integration tests, we can do a lot of stuff as well. So usually integration tests that are most interesting for GraphQL servers are ones where you would actually mock your schema or maybe mock just the entire server and test your resolvers. So you actually want to see if your queries function as expected. So for this you can actually mock servers, which can be quite easy if you maybe set up your GraphQL server with Apollo, or maybe if you've done something else. It shouldn't be that hard to create mock information. Maybe you can create an entire mock server as well, directly in Postman or something else. So we can see with the integration test and mocking APIs, it's usually something like this, right? So you mocked your API, but actually there's nothing behind. There's no database. So you don't have to worry about database connections when you're testing your, you're doing integration testing your GraphQL server, because you don't actually need internet connection and it can just run in your CI. So I've made a small example with Apollo for this. And with Apollo, it's really easy when you create your GraphQL server to actually implement mocking as well. So it's basically just done like this. So you define your resolvers, you define your schemas with your type defs, and then you create your Apollo server. And you put in one extra field, and that's mocks is true. And when you insert this, your entire schema will be mocked. And also, if you want to have more advanced use cases, you can also have your resolvers mocked. So maybe you want resolvers to mutate your data in some way, then you would define like custom mock resolvers to get the data there. And you can actually use it together with Postman as well, because the newest Postman releases, they've got the option to send in a GraphQL query as a body request, as a body type. So as you can see, it's only in the beta field, but you can actually, there's a small trick for it. If you're using older Postman versions, you can just change the content type to application/GraphQL, and then it should work as well. But let's try this. So yeah, let's look at this first. So I've got a server defined here. Let's refresh it just to be sure. Yeah, so this one's still running. I've got a server defined here, and we want to mock this, right? So we can just add this one here. It should be interesting to see how the mocking will work. So we can just do it like this. And maybe we can test a small query here. So this is actually a products query, which you just saw. So we're getting ID, title, thumbnail, some other fields. And now this is actually the data you want to receive, right? So you're looking for products, you get stuff like a blue t-shirt. That's probably correct. So if you implement mocking for this, refresh it here as well. It's mocks, sorry. Okay, so if we add the mocks to there, now you can see we got like hello world, we got strange digits. So now you know your data is mocked. So this is actually mocking based on your schema. So you can also mock based on your resolvers. So maybe if you have more complex situations you want to test. But for now, just mock our schema. So as you can see, we got stuff like hello world. The digits will change all the time because every time you send this query, it will be mocked. So you got like fresh data to test with. So that's all done on this server, and you can find the type definitions here. So these are all stuff we can test you in a request. So if we would go to Postman, so we've got, this is actually the code sandbox I'm using to test this one. Yeah, so as you can see, I'm not sending any params, but I'm sending a body. So in my body, I can use this new feature from Postman to actually test my queries in here. And something I can do is like actually sending this one and look at the results. So this is the old one with the blue t-shirts, and then we can send a new one, and it would actually get the same mock data as we saw in the GraphQL playground. So with this mock data, we can actually send up test scenarios in Postman, because you can test over there as well. And if you're working on larger APIs that you also want to share with other team members or maybe companies that are working with your APIs, then Postman is really convenient because you can make collections, you can make mock servers, you can also monitor stuff. So if you have other people using your APIs, you can monitor it all from there. So if you would want to test your GraphQL servers in here, you can just create some test scenarios for them. So I already created some. So one I already created was seeing if my response time is less than 200 milliseconds. So this one, it's a bit, you don't really know if the actual response time of your server will be that when you mock it locally. But maybe if you've got a server in place, you can test this here. And then we can see if products is an array. So when my products data is being sent, is being received, like here, you can see it's an array. So these are all things you can test. Or maybe you can see if reviews is an object. And you can go even further by maybe testing of the reviews count is like a float or a number. So we can do it like this, or maybe we can just see if like the product's title is a string. Maybe it's easier. So you could just go in like here, maybe we would have title. And then you can see I've added like a test case, and this one works as well. You can immediately see if somehow someone changed your API. You don't never know if there is any versioning in place or there are a lot of people working on your API. If somehow this string ends up to be like maybe an array or an object or an integer, you would know if you monitor your APIs in here. So this is really convenient to work with. Like before, when I worked with REST APIs a lot, I used Postman on a daily basis. Then came GraphQL, and mostly used the playgrounds. But now with this new feature, I actually start using Postman a lot again. And it's got a lot of functions that you don't have in a regular GraphQL playground, which is quite basic. Yeah, so if you would want to have this test, this code for the server as well, you can get it here, and you will get redirected to the code sandbox, where you can find like all the sample code to set up the server. And you can create your own testing, or maybe you can use it as a backend for something else. Okay, so we can also test on the client side. And testing on the client side can maybe be a bit more interesting, because it's actually where a user is using the app, using GraphQL server. So maybe you run into new problems, maybe there is something you didn't oversee when you created the server. So let's look at client-side testing. So again, I used JavaScript to create this one, and I'm making something with React Apollo. So what I've done here, I want to test this component. So if you aren't familiar with React Apollo, basically what it does, it gives you some components that can handle your data flow. So if you can look at this query component, if you input a GraphQL query in there, it will automatically parse it for you. We'll do the fetch request, and it will return things like loading, error, and data. But you want to test if this actually works, right? Because you're using an external component that you didn't write yourself. So it could be interesting to test this component. And as you can see, this component should in the end fill my divs and my age elements with data from that GraphQL API. So we'd actually want to see if title is displayed or not, and whether or not your GraphQL server returns this field. So if it returns this field, that's something you could already have tested on your backend side or with Postman if you want to monitor it externally. but to do it from the client side, you need to implement some other things as well. So there are multiple ways to do this. So one thing to do this is by actually mocking the provider and actually mocking the entire client. So this is quite easy and fast to do, but still it isn't that reliable. But still, look at how we can do it. As you can see, you're actually mocking the entire result that comes back from your GraphQL server. So this one, it isn't really reliable, because still, if you change your mock data, then maybe it will work in your test, but maybe it doesn't work in your actual application. But suppose it does, you can see you've got a request, and your request has a query, and it's got a result. And your result should have some data structure that's similar to the one returned by a server, and you can just mock it and see if your component works as expected. So this is sort of like a unit test for your query component, to see if this component will actually function as you would expect it once you give it mock data. As you can see, we tested several things. So we're actually going to find our H element, and we're going to see whether or not our text is rendered in there. So you can test it with this, and your test is in the mock, so it shouldn't be that hard. So you're basically just testing the function of the JSX component. And also, this is something I've got some code for. So if you're interested in this, it's using the same server as you saw before. So if you would run them both, you would actually have a full stack GraphQL application that uses JavaScript on the back end with Apollo, and JavaScript on the front end with React, and also Apollo. So if you would look at this example, so first check if we still have a server running, because we would need that one. Yeah, so we still have a server running. And then we can go and look at this one, right? So I've basically set up a very small application that's using Apollo and React Apollo as well. As you can see, I'm using the GraphQL server I just created also in Code Sandbox, and I've got a provider here where I attach the client to, and then I'm rendering the products. So you can see what this looks like in the browser. So this is nothing fancy, it's just like a list and some input fields. So if I would type something in here. First let's make sure we turn off the mock here, because we want real data. Yeah, so we've got real data now, and we could just add some fields to it. And adding some fields to it, as you can see, it returns a success message as well. So these are things you might want to test. And also you want to see whether or not there are more items in this list. So again, yeah, we set up this basic application, and this application has some tests in there as well. So the first test we can look maybe is for the product. See, we're testing multiple things in here. So we're going to test if it renders without error. We're going to test if it shows any loading indicator once the server is loading. And we're going to see if it actually renders the products. If you look at the product component, it just takes a query, which we already saw before, and which we have also tested in Postman. And then we're going to pass to the query component, and we might do some stuff with there. So we have a loading, we have error, and if there isn't any error, we're doing things with it, like mapping it, showing a title. So these are things you can test. So you could use maybe snapshots, like Code Sandbox doesn't support snapshots, so that's why I left them out here, but you could test with a snapshot, just look at like your component looked like, but still it's an easy test, but not that reliable. And you could see if it renders the loading state. As you can see here, we're testing whether or not the loading state is displayed. So there should be somewhere loading displayed in your component tree. And then you can check if it actually renders products. And for this, we're using mock data. So still, it isn't that reliable, but it's something to see if your UI works as expected. And you can just see if you put those mocks in there, whether or not the title is displayed. And you can also do the same for error messages. So maybe you want to see whether or not an error message is displayed whenever your server isn't available. So these are just tests for products, and for form, they're quite the same. So I want to see whether or not it renders without an error, whether or not the loading indicator is shown, if you can add an offer, so if the added message is shown, whether or not extra fields are added. So these are things you can test as well for your form. So, which you can see in here. So I created some mocks for the refs, because refs are a bit tricky to mock. So if you want to create controlled components, don't use refs, because they're really hard to mock. So in here, we're just going to see whether or not your component loads. We're going to see if the loading state is somewhere in there. And again, we're using all mock data. I basically do the same for adding offers and rendering success messages. So if you would want to get this code, you can just use this QR code and find it on Code Sandbox and play around with it. And so yeah, so to have end-to-end testing, you would have a more complex one, right? Because you also want to test how your server behaves. So if you wanted to do that, you can just test using the real Apollo provider. So just testing against real life data, or maybe real data from your test GraphQL server that's using some test database. So basically all the implementation would be the same, except you can leave out the mocks, and instead of mocks, you're using the actual data. So that's way more reliable. Something else I would like to do, there are packages to help you do this, is actually importing your schemas or importing fields from your actual database, actual GraphQL server, and use them as mocks. So then you would still have a reliable implementation. So as I said before, you can also do load testing. So as a small extra demo, I've included something to do load testing with. And basically what I've implied is another package from Easy GraphQL. So that's called Easy GraphQL, and then there's load tester. And with this one, you can load test your applications. You could send a certain number of queries to it, a certain number of mutations. You can add your own variables, and then you can choose how many private users you want to test it on. So this is actually really convenient if you want to find out how your actual application would scale. So maybe you built a GraphQL server, everything works real nice. You've got queries that maybe have a nesting depth of like 6 different fields. It could be really interesting to see how this would scale. So with stuff like this, you can actually test how it scales. So let's see how it looks like. So basically, we're gonna test this GraphQL server. So while it loads, I'm gonna work it through it. So basically what you're doing here, you can define certain things. You can define whether or not you want queries, whether or not you want mutations, the duration, the arrival rate, whether or not you want to see the output on your right side as well. And then you can define arguments. So these are the arguments for the query get student by ID, and this from get career. So you can just define arguments, and yeah, this is something you got to define for yourself. Do you want the same arguments? Do you want different arguments? These are all things you can implement. And then you can set input variables for maybe mutations. So let's see if we can run this one. So now you can see it's first it's going to set up the application. So it's actually going to mock a client that will send all these queries to your server. So this might take some time. Yeah, so what you're seeing right now is just like getting node modules that you would need to actually run a GraphQL client. And now it's going to send all these requests. So this is a lot of requests being fired at your GraphQL server. So maybe if you've got an unstable database, you will find out after running a test like this. So as you can see, this one was quite fast because I put a duration of just 1. And as you can see, there are 50 scenarios launched. We've also got 50 completed, so that's good. Nothing crashed. And also there were like 1050 requests being sent to your server. So you can probably imagine like within 10 seconds or so being 1050 requests sent to your server. I don't know if you've ever looked at the GitHub GraphQL API. They actually limited the amount of requests you can send. And that amount is way smaller than actual REST API. Because with all the nesting and you don't know how deep people will go and you've got a lot of relations, then it can be quite tricky to implement that well. So if you don't have any load testing for that, you will probably find out sooner or later that your queries might be too big, or you maybe have to find too many relations that are queryable. So as you can see here, all went well. You can also try running it with maybe like more or a different arrival rate to see how this will actually implement your setup. So that's a package you can find right here. And the only thing you need to configure it is just trying to run a bash script, which you can do locally, and you would define a config file, and there you would put in all the variables and some configuration amounts for like the number of requests you want to send. So if we would want to wrap this all up, like look at everything we saw. So for testing GraphQL, there are a lot of things we can do. So we can do static type checking. So that's where static type checking, where we'd actually have TypeScript or another functional programming language using types. So within here, you can already get a lot of your, you can already do a lot of debugging, because maybe you will find out when you actually have compiled everything that there were errors in there. So really, to get end-to-end type safety with GraphQL, you would need some static type checking. And if you don't implement any static type checking, it's really interesting to actually have a lot of unit tests for your code, because you want to know if your strings will remain strings, because otherwise they will definitely break your code. So if you try refactor GraphQL resolvers, or maybe you make changes to your schemas, a lot of things can break if you don't define your types well. And maybe if you've got side effects in your resolvers, you're actually changing the form of types, that could be tricky as well. So that's why you would need unit tests to make sure that these things are in place, and together with static type checking, they are sort of the basis for your testing. So if these things are in place, you've got probably sort of a stable code base that can easily be added new features without breaking a lot of things. And then integration tests become a lot more tricky. So as we saw, you can mock your server and then try testing it with Postman, or maybe you can mock your server and test it in your client, or maybe you can mock the client and test your actual server. So for integration tests, there are a lot of options. So whatever type of option you choose, it really depends on what you're building and how complex it is. So maybe your client is really important, and maybe your GraphQL server not so. Then we'd implement more integration tests over there. And we can also do end-to-end tests, where you just test the entire life cycle. So you would have your schemas that are being tested by actually querying a version of your server, and you would have the client and actually see how your data flows to your client, and actually if titles will be rendered when you ask for, when you have a query, where's a title in there. So then you can actually apply end-to-end testing and really see if your life cycle from your GraphQL server to your client is working as expected. And then we also have load testing. So this one might be, it's really dependable on how many servers you're using. Maybe you're running serverless, and then you wouldn't really have to worry about this just for the large bill for Amazon, maybe at the end of the month. So with load testing, you can also, it's not really just testing if you need more servers, but also if you haven't written too complex queries. Because you have got maybe you're working with a SQL database on the backend, then you can easily get like nested a lot of relationships when people put in quite serious queries. So that's stuff to think about when you create your types as well. And then something that's important to mention is like 100% test coverage doesn't mean that you don't have any bugs. So bugs can arise everywhere. So maybe there are side effects you haven't tested. Maybe there are side effects you have tested, but actually something else is going on. But test coverage is like a good metric. If you've got some sort of test coverage, I don't know if you're using JavaScript with Jest, you can generate these summaries of your code. You can actually see, are my most important things tested or not? So something that Jest doesn't really see is important. So maybe whether or not a label like sold out, or maybe if you've got an e-commerce store. So that's a lot of things I work on, our e-commerce stores or marketplaces. When you try to render a label next to a product that either says sold out or hot item, or maybe low in shipment, for Jest this will be just a branch with a small percentage. So maybe you have 100% and then this is tested. Maybe you have 80 and this isn't tested. So 80 won't say anything. So just to keep in mind, just look at those test summaries and really see if you test the important parts. So then we'll have a small question, like if you implement GraphQL, would you really prefer like to have a lot of unit tests and static type checking and integration tests on top, or end-to-end? Or would you really prefer to have like more end-to-end testing and integration tests as well? So we would prefer the left setup to test it. Some people do. Do people prefer the right one as well? Ah, we've got some. Are you product managers? Ah, that's good. Now, something I like about the right one is because with GraphQL you've got a lot of different layers. It's also nice to test your client with actual real data, because GraphQL servers a thing with them that you don't really need versioning, because types can change all the time. It could be interesting to really have those end-to-end tests in place as well. So if you want to learn more, you can also find me on social media and ask your questions there. Or you can just find me on YouTube. I've got a lot of videos online and from other conferences, and also from NDC in London, if you want to know more about GraphQL. So those are things where I really explain the difference between using GraphQL and REST. And most of the times I write these things in JavaScript. I also use Reason and OCaml a lot, so if you have questions about those things, you can ask me later. If you really want to get started with testing in GraphQL easily with JavaScript, then I would really advise you to go to Apollo, because they've got a lot of documentation, both for running integration tests, also for server mocking, for testing resolvers. Basically everything is in there. And if you've got more experience with testing, you can also check out the Easy GraphQL tester and then have a look at them, because you can also mock your schemas, you can mock resolvers, you can test resolvers, make test assertions. So basically everything is in there. And also you've got the load tester, which is important to mention. Yeah, so thank you for your time, and if you have any questions, please let me know.